So before we start configuring ASP.NET Core Identity, let's take a look at what this actually is. And ASP.NET Core Identity is really just a membership system, and it supports the ability to log in based on users that are stored in Identity. It also supports external providers, so if we wanted to add Facebook login or Google login, then this is entirely possible using the ASP.NET Core Identity system. And whilst that isn't covered in the main part of this course, it is something that will be covered in the bonus section when we look at identity in a little bit more detail to cover some of the slightly more advanced concepts. But we're not going to cover that in this particular section. This section is big enough without adding this functionality as well. ASP.NET Identity also comes with some default user stores. When we introduce identity into our application, what this is going to give us is several new tables in our database, all to do with identity. Now, the one that we'll focus on in this course, the one that's going to store our users, is the ASP.NET Users table. And that's the one we'll be using in the main part throughout building this application. What ASP.NET Core Identity also gives us is access to a user manager. And as the name implies, this allows us to manage our users and create them and find them in our database. And we also have access to a sign-in manager, and this is going to be able to take our user name and password and compare it with the username and password in our database, and if they match, it will allow us to sign in to our API. So first of all, let's take a brief look at how our users are stored in our database. Well, not so much the users, but how are passwords stored in our database? And if we take this particular example where we're registering two different users, and both of them on this occasion have both decided to select the same weak password. Now, ASP.NET Core Identity is going to hash and sort these passwords before it stores them in our database. And what this will give us as a result, if it takes the same particular password and applies a hash and a sort to it, then both of these passwords are going to be stored as a hashed version of the password, or a hashed and sorted version of the password. And even though the passwords are identical, each user has a completely different password hash. And what this means is that if our database gets compromised, and somebody has access to all of our users' email addresses, they've got access to all of the users' hashed passwords, then each individual user's password hash would have to be cracked separately. Even if they've got the same password, the attacker would have no way of knowing that these two different users use the same password. Now, if they're using passwords like this, then it's not great anyway, but that doesn't make any difference in terms of cracking this particular password hash, because it's also being sorted as well. So there's no way to know, or there's no easy way to crack this particular password. I'm not saying it's impossible, because of course it's possible. But it's very difficult, and it's very CPU intensive, and it will take significant time for an attacker to crack each of these passwords, even though they're weak passwords, because of the hashing and the sorting before it's stored in a database. And if we take a look at the class that's responsible for hashing our password, then we get a description about the algorithm that's used to hash the password before it's stored in a database. And in this case, it's using HMAC shard 256 with 128-bit salt and a 256-bit subkey with 10,000 iterations. And basically, this means it's pretty well hashed. And the number of iterations is based on the fact that when we take a password and hash it once, we then iterate this hash. So then we hash it again. Then we hash that double hash. And then we keep going until we've hashed it 10,000 times. And that makes this particular hashed password very difficult to crack this. And the more times we hash a password, the longer it takes the CPU to complete the operation, and therefore the longer it would take someone to brute force the password if someone was to ever get the password hash. And as always, with the nature of what we store in our databases, we can't ever discount the possibility that our database will be compromised, so we always have to take care that if it is, then it's very difficult for an attacker to make use of the information stored inside it. And the goal is to buy time, because eventually, given enough time and enough CPU power, an attacker can crack a user's password hash. But the amount of iterations we apply here means that we give the user more time to change their password, because this will take a long time to go through all of our users and individually try and crack each of these password hashes. So this is the ASP.NET Core identity system that we're going to be setting up. For now, we're not going to return a token to the user once they successfully log in. We're just going to set up the structure of ASP.NET Core identity. And for now, just to prove that they've logged in successfully, we'll just return a user object. And after that, then we'll take a look at the token-based authentication. But first, let's set up ASP.NET identity.